Everybody stand for the opening prayer and let us feel the presence of the Lord. Amen. Good morning, class. Okay, before you take your seat, I want you to pick the pieces of paper under your chair, make your row straight, and have your chairs properly aligned. Thank you. You now take your seat. For your attendance, who is absent today? None? That is great to hear. So welcome class in our lesson in math. To start off, I have a few questions here. So do you have an idea when mathematics started? Are you familiar with ancient Greeks? And what do you think their contribution in Greek mathematics? To answer that, I will discuss to you it later. So let's proceed to our activities. For that, here are our rules. Please read. And with that, let us start. So, are you excited? You should be excited, class, because today we will have a game. So, are you familiar with 4 picks, 1 word? So, take a look at this. On this first activity, you guess the hidden words here by referring it to this picture, okay? So, now, this letter here below will serve as your clue in guessing the hidden words. So, let us start. Yes, Marianne, the hidden words are correct. Very good. Next. Yes, Iris, the hidden words are correct. Very well. And the last one. Yes, Miss Mayette, the hidden words are precisely. Because today, class, our lesson will be about the beginnings of Greek mathematics. And before we proceed to our lesson, let us have first the objectives so that we will be guided as we go along the discussion. So everybody, please read. Thank you. Alright, let us do the next activity. You will match the column A with column B, and you must suit the pictures to their respective names and select the best answer. Next, arrange the jumbled letters to form the words that are related to our topic. Let's see if those answers are correct. So, now class, for the questions, I want you to focus your attentions on the screen. Raise your hand if you want to answer the questions. So, are those names familiar to you? What particular topic comes to your mind after doing the activity? Yes, Hasmin? Fantastic! Greek mathematics seems to have been a detached intellectual for the connoisseur. All history is based on written documents. Although documentation concerning Egyptian and Babylonian mathematics is often very precise. So the primary sources that can give us the clear picture of the early development of Greek mathematics are bigger. So let us have first the dawn of demonstrative geometry, Thales of Miletus. So this is the geometric proposition. An angle inscribed in a semicircle is a right angle. A circle is bisected to its diameter. The base angle of an isosceles triangle are equal. And if 2 straight lines interact, the opposites angle are equal. The sides of similar triangle are proportional. 2 triangles are congruent if they have one side and 2 adjacent angles respectively equal. So how did Thales discover mathematics in Egypt? Raise your right hand. Yes, Carla? Awesome. Thales was the first to go into Egypt and bring back this learning geometry into Greece. He discovered many proportions himself, and he disclosed to his successor underlying principle of many others. In some cases of his methods being more general, in others more empirical. Thales is traditionally designated the father of geometry or the first mathematician. Thus, Thales knew already the distance along each side of the base of the Great Pyramid was 756 feet and that his staff was 6 feet long. So it was necessary only to measure the shadow of the pyramid and the shadow of the staff. It was 342 feet from the tip of the pyramid shadow to the edge of the base, and the shadow of the staff measured 9 feet. Now, Thales had all the required dimensions for the items of the proportion would give him the missing fourth item. The height of the Great Pyramid was h equals sh over h equals 378 plus 342 times 6 divided by 9 equals 2 over 3 times 720 equals 480 feet. So let's move on to Pythagorean mathematics. Pythagoras was born between 580 and 589 BC on the Aegean island Samos. Pupils concentrated on 4 mathemata or subjects of study: arithmetica, arithmetic in the sense of number as theory opposed to calculation; harmonia, music; geometria, geometry; and astrologia, astronomy. This fourfold division of knowledge became known in the Middle Ages as the quadrivium. When Pythagoras was close to 60 years old, he married one of his pupils, Theano. She was a remarkable mathematician who not only inspired him during the latter years of his life, but continued to promulgate his system taught after his death. The symbol on which the members of the Pythagorean community swore their oaths was the tetractys or holy fourfoldness, which was supposed to stand for the 4 elements: the air, water, air, and earth. The tetractys was represented geometrically by a lateral triangle made up of 10 dots, and arithmetically by the number 1 plus 2 plus 3 plus 4 equals to 10. To Pythagoras and his followers, mathematics was largely a means to an end, in which the human spirit was enabled through a mystical contemplation of the good and the beautiful. Nicomache's Introduction, Arithmetic, the most complete exposition that has come down to us, the arithmetic of Pythagoras, and his immediate successor is contained in the Introduction, Arithmetic of Nicomachus of Gerasa, circa 100. The numbers 1, 3, 6, and 10 are examples of triangular numbers because each of these counts the number of dots that can be arranged evenly in an equilateral triangle. Similarly, the numbers 1, 4, 9, and 16 are said to be square numbers because as dots they can be depicted as squares. For instance, the sum of 2 consecutive triangular numbers always equals the square number whose side is the same as the side of the larger of the 2 triangles. This can be confirmed geometrically by separating the dots with a slash and then counting them as in the accompanying figure. The Pythagoreans may have proved these results by first considering these equations. 1 squared equals 1. 2 squared minus 1 squared equals 3. 3 squared minus 2 squared equals 5. 4 squared minus 3 squared equals 7, and so on. It is equal to 2n minus 1. The theory of figurative numbers. In 1665, the mathematician philosopher Pascal wrote his treatise on figurative numbers. In it, he asserted every positive integer was the sum of 3 or 4 or fewer triangular numbers. For instance, 16 equals 6 plus 10. 25 equals 1 plus 3 plus 21. 39 equals 3 plus 15 plus 21. And 150 equals 6 plus 66 plus 78. Next, let us add horizontal rows considering 1, 3, 6, and 10 dots, respectively, to form a rectangle of width 1 plus 2 plus 3 plus 4 and height 4 plus 1. This is pictured here geometrically. Counting the dots in the squares and rows should make it clear that 1 squared plus 2 squared plus 3 squared plus 4 squared plus 1 plus 3 plus 6 plus 10 is equal to 1 plus 2 plus 3 plus 4 times 4 plus 1. And consequently, that 1 squared plus 2 squared plus 3 squared plus 4 squared equals 10.5 plus 20 is equal to 30. 4 times 5 times 9 over 6 is 30. Proceeding along similar lines, one can get a formula for n squared. So all in all, we have shown that the sum of the first n squares has a simple expressions in terms of n, namely 1 squared plus 2 squared plus 3 squared plus n squared is equal to n times n plus 1 times 2n plus 1 all over 6. So a strikingly original proof of the last result propounded by the 13th century mathematician Fibonacci comes from the identity k times k plus 1 times 2k plus 1 is equal to k minus 1 times k times 2k minus 1 plus 6k squared. So, let us move to Zeno's paradox. Zeno is remembered today for classical paradoxes preserved by Aristotle and his physics about the reality of motion. Zeno was originally a Pythagorean and, like Pythagoras, played an active part in the politics of his native city. So the paradox most often quoted concerns Achilles and a tortoise. Achilles, the swiftest runner in Greece, can never catch a tortoise that has been given us a head start. For by the time Achilles reaches the tortoise starting point, the animal will have moved to another point. By the time Achilles reached the point, the tortoise will advance somewhat further. As true, the faster runner always advances on the slower tortoise, yet cannot overtake it. Suppose that Achilles runs 10 times as fast as the determined tortoise and gives it an initial start of 100 yards. Say, Achilles runs 10 yards per second. Consider the distance he has to cover. They successively 100 yards, 10 yards, 1 yard, 1 over 10 yards, and so on. So the total number of yards Achilles must travel in order to catch his lower competitor is 100 plus 10 plus 1 over 10 plus 1 over 100, and so on. Accordingly, when Achilles has traversed 111 and 1 over 9 yards, he will be dead even with the tortoise, and ahead of him thereafter. Now, let's move on to the Pythagorean problem. Pythagoras had discovered the theorem. Now, the area of the same square can be represented in two ways, as the sum of the areas of two squares and two rectangles. So a plus b squared equals a squared plus b squared plus 2ak. And as the sum of the areas of a square and four triangles, a plus b squared is equal to c squared plus 4 times ab over 2. A diagram in the arithmetic classic represents the oldest known proof of the Pythagorean theorem. The proof, inspired by the figure, was much admired for its simple elegance, and it later found its way into Bija-Ganita or root calculations of the Hindu mathematicians Bhaskara, born in 1114. Early solutions of the Pythagorean equation: x squared plus y squared equals z squared. So a triple xyz of positive integers satisfy equation is said to be a Pythagorean triple. So ancient tradition attributes to Pythagoras himself a partial solution of the problem expressed by the numbers. So x equals 2n plus 1, y equals 2n squared plus 2n, z equals 2n squared plus 2n plus 1. As you can see, n is 1, 2, 3, 4, 5, x is 3, 5, 7, 9, 11, y is 4, 12, 24, 40, 60, z 5, 13, 25, 41, and 61. As one sees, Pythagoras' solution has the special feature of producing right triangles having the characteristic that the hypotenuse exceeds the larger leg by 1. So the crisis of incommensurable quantities, the most important achievement of the Pythagorean school in its influence of the evolution of the number concept was the discovery of the irrational. The oldest known proof dealing with incommensurable line segments corresponds in essential to the modern proof that square root of 2 is irrational. So, the ratio of this segment is AC over AB equals M over N. To make matters simpler, let us suppose that any common factors of n and n have been cancelled. Now, AC squared over AB squared is equal to M squared over N squared. Applying the Pythagorean theorem to the triangle ABC, one gets AC squared. It is equal to 2AB squared, so that the displayed equations becomes 2 equals M squared all over N squared. Next, Theon side and diagonal numbers. Theon of Smyrna, or circa 130, devised a procedure for reaching closer and closer approximations of square root of 2 by rational numbers. The computations involve two sequences of numbers, the side numbers and the diagonal numbers. We begin with two numbers, one called the first side denoted by x sub 1 and the other the first diagonal indicated by y sub 1. The second side and diagonal x squared and y squared are formed from the first, the third side and diagonal x sub 3 and y sub 3 from the second, and so on according to the scheme. In general, x sub n and y sub n are obtained from the previous pair of side diagonal numbers by the formulas x sub n is equal to x sub n minus 1 plus y sub n minus 1, or y sub n is equal to 2x sub n minus 1 plus y sub n minus 1. If we take x sub 1 is equal to y sub 1 is equal to 1 as the initial values, then will become to this. So let's move on to Eudoxus of Cnidos. The Greeks used the term logos, meaning word or speech, for the ratio of two integers. Hence, when incommensurable lengths were described as alogos, the term carried a double meaning, not a ratio and not to be spoken. It fell to Eudoxus of Cnidos, 408 to 355 BC, to resolve the crisis in the foundations of mathematics. His great contribution was the revised theory of proportion applicable to incommensurable as well as commensurable quantities. It was a formidable task and engaged the best efforts of the most notable mathematicians of the 4th century BC: Theodorus, Theaetetus, Archytas, and Eudoxus. Theodorus of Cyrene, born 470 BC, the mathematics tutor of the great philosopher Plato. Perhaps the most brilliant Greek mathematician before Archimedes was Eudoxus. So, the three construction problems of antiquity. The mathematician who dominated the second half of the 5th century BC was Hippocrates of Chios, who is to be distinguished from his more celebrated contemporary Hippocrates of Kos, the father of Greek medicine. Hippias of Elis, a near contemporary of Hippocrates, invented a new curve called the quadratrix for the express purpose of squaring the circle. His solution was perfectly legitimate but did not satisfy the restriction Plato had laid down. Hearing that Hippias had devised a sliding apparatus by which his curve could be drawn, Plato rejected the solution on the grounds that it was mechanical and not geometrical. The last one is the trisection of an angle. In the special case of the right angle, POQ, the construction is found as follows. With O as the center, draw a circle of any radius intersecting the sides of the angle in points A and B. Now, draw a circle with center at B and passing through O, the two circles will intersect in 2 points, one of which will be a point C in the interior of angle POQ. Okay class, all of those, everything you've done and observed are the beginnings of Greek mathematics. So now, let's have some brave souls summarize this concept yet again. Yes? Very good definitions. So class, before we proceed to your evaluation, I want you to read this. So this is one of the Pythagoras saying about this topic. And I want you to reflect on that next meeting in essay form and be creative. But for now, let's proceed to your evaluation. So this is multiple choice. I want you to select the best answer of each of the following questions and do this for the remaining time. So thank you for your active participation today. Goodbye class.